Pythagorean theorem. So all of module 12 is about the Pythagorean theorem and the different ways we can use it. So the most important thing will be memorizing the Pythagorean theorem. So I can use the Pythagorean theorem to solve for missing side lengths, that should say, of a right triangle. That's why I teach math. I'm going to fix that because it bothers me. There we go. So the Pythagorean theorem is only used in a right triangle. And so the very first part of it is that the triangle is a right triangle. Like you have to have a right triangle or this doesn't work. Okay, so this is definitely the most important part of this, is that it has to be a right triangle or there's no use for using the Pythagorean theorem to find missing pieces, okay? So what it says the sum, so remember sum is addition, of the squares of the lengths of the legs is equal to, right, we know this is an equal sign, to the square of the length of the hypotenuse. And the easier way, the way most people say it, is just a squared plus b squared equals c squared. Okay, so a squared and b squared is the sum. See how they're being added together. Square, meaning we squared them. The lengths of the legs. So A is what we would call a leg. B we would call a leg. And then it says it equals the square, so there it is right there, of the length of the hypotenuse. So C is always going to be the hypotenuse. Always. So down here we have the definition of what a leg and a hypotenuse is. So the leg are the two sides of a triangle that form the right triangle, okay? So when we have a right triangle, you should draw this as well. There's my little right triangle. This is a leg right here, and this is a leg, because they're the two sides that form the right angle of the triangle, okay? So that's why we would call those the legs. So they make the right triangle, the right angle of the triangle. So the hypotenuse is the side of the triangle that's opposite. Wow, I had a really hard time typing the word opposite, apparently. Opposite. The right angle. It's also always the longest side. So again, if I drew my right triangle, so there's my right triangle, opposite of it, this is my hypotenuse. That's not a really great Y. There we go. It's always opposite and it's always the longest, okay? So I would definitely draw these pictures and label these things. It's really, really important. And you can pause, obviously, if you need a little bit more time to write. So we have this right triangle. See right there, it's told me it's a right triangle. So then I can use a squared plus b squared equals c squared. So we're going to take a squared plus b squared, set it equal to c squared. So remember, the c, or the hypotenuse, is always this one across from here, so we can label this letter C. Remember, A and B are the legs, the sides that make the right angle of my right triangle. So it doesn't matter which one you label A or B. So maybe we just call this A and this B, and maybe you always just call the height A and the length B to keep it consistent if you would like to. So once we have everything labeled, we can then fill in our equation. So A becomes 7, so we're going to go 7 squared plus 24 squared, and it's going to equal c squared because that's the piece we have missing, is the hypotenuse, the one across from the 90 degrees. So in our calculator, we would do 7 squared, that's 49, plus, again, 24 squared is 576. Equals c squared. We would add them together, get 625, And then notice that says c squared. I don't want c squared, I want c. So we have to remember what the inverse of squaring something is, and hopefully you remember from the review and talking about it a little bit during 2 units ago. We would square root it, right? And so I'm going to just push my square root button, and we would get 25 equals c. This is exactly how your work needs to look, because it's important, because if you put these in the wrong place and just start typing in your calculator, there's no way to know if you put them in the right place, okay? Also, if you accidentally square it wrong, we don't know what you got here. So this is exactly how your work should be modeled from top to bottom, okay? All right, so here's option B, or problem B. And the difference with problem B is that one of our legs is actually missing, not our C. So this is always going to be C, the one that's across from the 90 degrees. Again, maybe I label this B and the missing piece A. Like I said, this doesn't matter, but this always does. If you want to keep it consistent, always the height A, length B, but it doesn't have to. So I'm going to fill in my formula. I'm going to go A squared, because I don't have A, plus 12 squared, because that's what I labeled as B, equals 15 squared, because that's C. So this form right here never changes, just how we solve it, it's going to slightly change. So I'm going to go A squared plus, well, 12 squared is 144, equals 15 squared, which is going to get 225. So far the work has been identical to what we did up above. The only thing is, before we can finish, we're actually not going to add things together like we did here. We're going to actually do inverse operations and subtract here. We get A squared equals 225 minus 144 would get me 81. Just like here, the inverse of squaring something is square rooting something. And we get A equals 9. So a couple ways you can check that if you're doing your work okay is, like I said, the hypotenuse will always be the longest side. So where we solve for C and we got 25, at least we know we're on the right track, because it's bigger than both of these, which is what I need. When it comes to solving for like A or B, it always needs to be smaller than C. So we know we're at least on the right track, because 9 is clearly less than 15. If this had come out as 18, we would have a problem, because C is 15. It can't be bigger than that. Okay, so that's a check for you. All right, so we have a box that's used for shipping narrow copper tubes, measure 6 inches by 6 inches by 20 inches. So length, width, height. What is the length of the longest tube that will fit in the box, given that the length of the tube must be a whole number in inches? So if you notice the bottom right here, it's made a triangle for us. So there's a couple of ways you can lay objects inside of boxes. One way is this way, where it lays flat on the bottom of the box, right? So because we know this is a rectangular prism and it's a box, we know that this is going to cause a right angle, because it's a rectangle, right? And that's a part of the definition of a rectangle. So we know the length is 20. So maybe in this case we write B. Okay, so B is going to be 20. We know that the height of my right triangle is 6, because, right, we can scan it over here and it's going to be 6. So that's going to be my A. And what I'm trying to solve for is S. And in our case, S is really just C. So we're going to go 6 squared plus 20 squared equals S squared. 6 squared is 36. 20 squared is 400 equals S squared. We're going to add these together. 436 equals S squared. We're going to take 436 and square root it. It does say round to the nearest whole inches, right? Given the length of the tube is in a whole number of inches. It says if you do this in your calculator and we square root, it's a 20.5 0.88 is approximately S, but it does say whole inches. We can't go above that or it won't fit, so we would just say about 20 inches, right? Because if we go more, it's not going to fit across there. Now, if you notice, there's another triangle drawn in here. I'm going to do this in red. Is that you can actually lie things inside of a box diagonally from top to bottom. And what it's going to do is it's going to cause, kind of losing my line there. It's going to make this right triangle. And again, the reason we know it's a right triangle is because right here on this rectangle, it's going to make a perfect corner, okay? So in this case, we're going to use this height. So height we normally been labeling as A. So our A for the second triangle is going to be 6. Now, if you notice, B is actually our S. So B is equal to S, which if we remember is about 20. And then C in this case is our R, because you can see it's the one across from the 90 degrees. So 6 squared plus, now I'm going to do something, I'm going to have you watch this, S squared equals R squared. Now the reason I did that is because technically S is an estimate. We rounded here, I technically rounded here, but if you look right here, I had what S squared equaled perfectly. So we can actually do 36 plus 436, because right here is S squared. And so I don't have to use the estimate, because if I have an exact number right here, I'm going to want to use it. And that's going to get us R squared. So I'm going to take 436, add 36, and we're going to get 472 equals R squared. And we are going to square root, because that's the inverse. We initially get 21.725 is about R. So we would say what is the length of the longest tube that will fit in the box given the length of the whole number. We would say 21 inches, because that's what we would round this one to. Okay, again, I can't round up, because if I did that, it would be too large. Okay, now the other reason we do not use our estimate for S from here is if I just plugged in 20 again, it would match and it would say it was the same exact number, and it was not going to be the exact same number. So we need to use the most accurate number we have, which is this one. This was an estimate, this was an estimate. We want to get as most accurate, which would be our S squared, okay? So this little extra step is necessary, okay? All right, we're going to practice another one, because I know this is kind of hard. So here's our next one. Maybe this would be a good time, though, for you to practice using the Pythagorean Theorem. I'll set it up, but it would probably be a really good idea for you to try practicing this. Maybe you set it up, and we'll see how it goes. So there's my blue triangle. Maybe look at the problem we just did and see if you can set this up and see if you can solve for S squared. It would be a really good time for you to pause. So the way I would do this is I would go 4 squared plus 14 squared equals S squared. This is 16. This is 196 equals S squared. I take 196 and add 16. We get 212 equals S squared. And to get S, we technically do square root, just good practice. And so it's about 14.56. And so we would say about 14. So that's how you would get S. So check your work, come with questions if that didn't make sense. So now I'd like you to go and try to do the red triangle, which is to help us solve for R. Again, look at the last example and see if you can solve for R. So we would do 4 squared plus, remember how I did s squared equals r squared. I then did 16 plus 212, because that's my s squared, equals r squared. I add 16 plus 212. We get 228 equals r squared. Square root it. It is 15.09. So we would say 15 inches. All right, so the main thing to remember is our formula, a squared plus b squared equals c squared. Okay, we need to remember that a and b are the legs. Okay, that's really important. And c is the hypotenuse. Yep, there we go. All right, so those are the main things to remember. All right, here are your independent practice problems. They are more similar to our very first two problems under the guided notes or guided practice. And you're just using a squared plus b squared equals c squared. All right, adios, until next time.